Assalamualaikum. My name is Abdullah Iman bin Azhar. My metric number is 2019-548-477. Today I would like to present about my topic, comparison between types of foot archers on power among Malaysian Navy. Okay, first of all, background of the study. Power is one of the most important physical attributes, especially in jumping movement, acceleration, and throwing. The target population is the Malaysian Navy from Royal Malaysian Navy based in Lumut. They are continuously involved in many physical activities, which requires them to have a high level of power in order from them to stay in the best physical condition. Okay, next. There are some studies that related the types of foot archers can eventually affect power. But the foot is classified into three following categories depending on arc height. First of all, there are pes planus, normal, and pes canvas type of foot. So, it may be the arc height influence the force acting between foot and ground. Moving next to statement of the problem. Eventually, there is a limited research found on foot biomechanics that related to power, especially in the types of foot archers. So, regarding this limited research, we need to do this research to gain more information about foot biomechanics that related to power, especially in the types of foot archers. So, in previous studies, the energy sparring spring theory of the foot archers has become central to interpretations of the foot's mechanical function and evolution regarding to Sterner 2016. But there is a relation to compression and subsequent storage and return of elastic energy in the foot's longitudinal arc affects the metabolic cost of locomotion. So that's the statement of problem. Moving next is research objective. First of all, this research is to identify which type of foot arc shows better result in terms of power, and also to compare the types of foot archers on power. Moving next to significance of the study. First of all, findings from this study can be useful for the coaches, athletes, and other researchers. This study is to contribute the theory and knowledge on how different types of foot archers affect power. And the findings should be able to help coaches to identify their athletes. And for another reason, it will be give solution according to restraining performance of athletes. This knowledge could be given to athletes and sport practitioners on how their types of foot archers are related to their power level. Moving next to literature review. Okay, first of all, the types of foot archers. Many studies have been made on the foot archers function. Human foot posture is generally characterized by alignment of foot skeleton and various considerable between individuals. First of all, there are pes rectus, pes planus, and pes cavus, which is categorized into three using the morphology of medial arc, seen by Guani 2017. First of all, pes rectus is normally a line foot which the arc height is within normal range. And this is also the bisector of the posterior surface of the calcaneus is perpendicular to the ground. Moving next to the arc height of pes planus is usually below the normal range, and the plantar aspect of the foot is complete or near complete contact to the ground, which is flat-footed. So Last one is pes converse is usually an abnormally high arc foot. Moving next to power. Power is mechanical principle of the rate at which the people does work or transfer energy to complete a movement task. So, muscle power combines strength with speed and movement coordination, basic characteristic for performing basic daily. So, basic daily tasks. And this perspective, declines in muscle power have been shown to be more important than muscle strength in the ability to perform daily activities. Other than that, the power produced by the joint of the body can be determined by the product of the neck joint Q and joint angular velocity. Thus, the unit for the joint power is Newton meters or watt. So, in addition, movement in human body is manifestation of force exerted primarily through muscle activity. So, this muscular activity can be result in eccentric, concentric, isometric types of action. So, moving next to relationship between types of foot arches and power. So, in these studies or research, the energy sparring spring theory of the foot arch has become central to this research about the foot mechanical function and evaluation. So, based on this study from Senate 2016, the longitudinal arc of the foot as an elastic storage return mechanism. So, based on this study, there is a relation to the compression and subsequent storage and return of elastic energy in foot longitudinal arc affects the metabolic cost of locomotion. So, in this, metabolic energy saved by the arc is largely explained by the passive elastic work to supply the wood, to supply the energy that would otherwise be done by active muscle, and it is the end range of arc compression that detected the energy saving role of the arc from the arc. Moving next to methodology. First of all, the research design. We using the descriptive and casual comparative research design. We will be used in the study. This research design is suitable with the research objective, which is to identify which type of foot arc shows better result in power. Research question and hypothesis of the study have been taken to align and selecting the design of the research. Casual comparative design will be used as the study to compare the independent variable of the type of foot arc and power, which is the dependent variable, and that have in between the different groups of high, medium, and low arc foot. So, the independent variable in the studies cannot be controlled. So, the result of the study will be analyzed from a one-shot data collection to control the extraneous of variable. Moving next to sampling, sample size and sampling technique. The number of population is unknown. So to determine the sample size of the study, coherent formula 1977 will be used. The estimated sample size to be taken from the total population is 39, with additional 20% of the estimate sample to avoid unwritten rate and drop out. So the total sample will be 46 samples. Okay. Purposive sampling of the non-probability will be sampling technique used to collect the sample from sample size estimated, as they cannot be selected randomly. So this is the inclusion criteria and exclusion criteria. First of all, for inclusion criteria, their health must be male, free from injury, BMI range between 18.5 and 24.9 to maintain the reliability of the test result, and the exclusion criteria is must not injured. So moving next to the instrumentation. First of all, the IV, independent variable, the type of foot arches. We're using the wet test. First of all, this test is, the water is put in the pan that should fit the foot, and the water is deep enough to wet all parts of the bottom of the foot. Then the subject will step into the water with one foot and carefully remove their foot from the pan. Next, they will be stepped on a cardboard and put their weight on it. Finally, the foot is removed from the cardboard and leave a mark or footprint to be taken for reference, and this process will be repeated with the subject other foot. Moving next to dependent variable power, we're using vertical jump test. In this procedure, the subject standing height was set on having the subject stand with the side of his dominant hand next to the wall and heels together on the floor. So then with a chalk at the fingertips, the subject gather himself in a semi-squat position and jump upward as high as possible and mark at the wall. So subject were not allowed to hop or go off one foot or walk into the jump. So the height jump is measured distance between the standing reach height and the jumping height. So each subject received 3 trials in succession with the time of 15 to 30 seconds of recovery between jumps. So the best of 3 jumps will be used to calculate the subject score. Okay, moving next to data collection procedure. Before starting the test, we will be informed ethical or consent form, ethical approval or consent form will be given to them, and they should be filled by every participant. So participants should be at good health condition and free from injuries before doing the test. And their BMI will then be measured and recorded to make sure that they are in the same range. And the type of foot arc will be measured by using the wet test to determine the subject's type of foot arches before assign them into the different groups. So next, the subject will do the vertical jump test. Subject will vertical jump test to calculate the power. Then subject, before starting the vertical jump test, subject will do a warm up before the test is conducted. And finally, the data collected will be arranged according the subject's type of foot arc and then analyzed to identify which type of foot arc shows better result in power. Okay, for the last one, data analysis. The research objective is to identify which type of foot arc shows better result in power and to investigate the relationship between types of foot arches and power. So, in this data analysis, IBM SPSS 26 will be used to analyze the data to compare the type of foot arches in relation to power. Descriptive analysis will be used to collect the data needed in order to analyze the mean. And also descriptive analysis will be carried out using mean and standard deviation. So while inferential statistics will be used to see the differences between groups of high arches, low normal, and low arches foot. So analysis of variance, which is ANOVA, will be used if the data distribution of the 3 groups were found to be normal, while Kruskal-Wallis will be used if the 3 groups data distribution were not normal. So the data of all variables that have been collected will be compared to every group to get the significance of the study. Between there is no significance or have a significance, and the statistical significant difference will be set up at alpha p below 0.5 or alpha 0.05, 0.005 below or above 0.05. This is the reference. of this research. And that's all for me. Thank you.